Today I will discuss about the divergence related problems and solutions. Most of the problems are taken from the Spiegel book. So let's start with a very simple problem. The problem number 70. This is in the supplementary problem in the Spiegel book. তাহলে Spiegel book এর supplementary problem এ তোমরা দেখতে পাবে. So first a vector field is given and a scalar field also given. So first it is a very simple. It is asked that what is the divergence of a vector. Divergence of a vector করে ফেলো. So del nabla vector, it is I cap del x plus j cap del y plus k cap del z, and it will be the dot product with the given field, that is 3x y z square I cap plus twice x y cube j cap minus x square y z k cap. So it is a very simple dot product, right? আর dot product খুব সহজ ব্যাপার, because the first term will operated on the first term, second term will be operated on the second term, and the third term will be operated on the third term, right? So del x will be operated on this I cap term, that is 3x y z square plus del y, because here is j cap, so here is also j cap, so it will be operated on the second term, twice x y cube plus del z, which will be operated on the minus x square y z. So del x of these things, so it will be operated only on the x term, remaining terms will be the same, so it is 3y z square plus del y of this one, it will be operated on this y term only, so it is del y of y cube, that means 3y square. 3y square multiplied with 2x, it gives you 6x y square minus del z only z, so it is x square z. But it is asked divergence of a vector at the point 1, minus 1 and 1. So just you have to put x is equal to 1, y is equal to minus 1 and z is equal to 1 here. Okay. So what you will get, it is 3 into minus 1 into 1 square, that means 1, plus 6 into 1 into minus 1 square, again 1, minus 1 into 1. So it's basically this is minus 3 plus 6 and it is minus 1. So I think I have done one mistake here. This will be x square y, sorry, this will be x square y, so it will be minus 1, so it becomes plus 1. So this is basically answer is 4, right? In the B, what it is asked? It is asked what is the A dot gradient of phi. So first what you have to find out at the same point, that is 1, minus 1 and 1. এই বিন্দুতে তোমাকে A vector dot gradient of phi determine করতে হবে. So what is the gradient of phi? We all know it is very easy to find out. The gradient of phi means this is gradient of 3x square minus yz. So that means del x I cap del x of this term plus j cap del y of this term plus k cap del z of this term. So first I cap del x of this term, that means differentiation with respect to x only. So x only and yz will be constant here. So it gives you del x of this term, that means I cap 6x del x of x square, that means 2x 6x plus j cap will be operated on this term on the y. So it is minus z plus k cap, it is also simple, it is minus y. So gradient of phi we have found out, it is 6x I cap minus z j cap minus y k cap. Then we have to perform the dot product A vector dot gradient of phi. What is the A vector? A vector is this one which is given here. So A vector is equal to 3x y z square I cap plus twice x y cube j cap plus minus x square y z k cap, right? And dot with 6x I cap minus z j cap minus y k cap. Dot product is a very simple things, right? Because I cap term will be dotted with I cap term, that means this will be multiplied only this one. So it is basically 18x square y z square, and this will be multiplied with this minus z, so it becomes minus twice x y cube z, and this will be multiplied with that one. So minus minus plus, so it is x square y square z, right? And we have to find out again at that point. So if you put x is equal to 1, y is equal to minus 1 and z is equal to 1, your answer will be minus 15 here. Okay, check by yourself. Okay, and the C problem here, it is an interesting one, because at that point we have to use a formula. এখানে আমরা একটা formula use করব কি না, it is asked divergence of phi a vector, right? And we all know that divergence of phi a is first gradient of phi dot a vector, because nabla when associated with a scalar function, basically it is a gradient. তার কারণ ন্যাবলা যখনই কোনো স্কেলার ফাংশনের সঙ্গে যুক্ত হবে সেটা হচ্ছে গ্রেডিয়েন্ট, প্লাস nabla, how nabla can be associated with the vector function? Through the dot product, right? So phi will be there, so divergence of a vector. So we already have this, what is the gradient of phi? We have this gradient of phi, we already have a vector, we already have divergence of a vector. If you right now just if you calculate that one, you will get the answer will be 1. So this is home task for you. D, what it is asked? It is asked that what is the divergence of gradient of phi. So I will do it for you. So divergence of gradient of phi, either we can just use the what is the gradient of phi and then we will take the divergence, or simply we can, this is divergence of gradient of phi, that means it is nothing but the grad square phi. And what is the grad square? Grad square means del 2 del x2 plus del 2 del y2 plus del 2 del z2. This is the grad square, it will be operated on the phi, right? So that means del 2 phi del x2 plus del 2 phi del y2 plus del 2 phi del z2, right? So phi is already here, phi is equal to 3x square minus yz, so that is del 2. So I will not write this one, will be operated on the 3x square minus yz. That means I have to differentiate 2 times of this function, first with respect to x. So if I differentiate the whole term with respect to x 2 times, so it gives me, first I will get 6x, প্রথমে আমি কি পাবো, del del x of 3x square means 6x. Again if we do one more times differentiation, then it's only give me the 6. And if I differentiate this term with respect to y 2 times, first I will get minus z, because it will be operated on that term because y is here, and the second del del y of z gives you 0, right? Similarly del del z of yz gives you minus y, and again if I perform the second time differentiation, it gives me 0. So basically this is 6. Okay, so now let's move to another problem. I think it is problem number 72. The problem is that a scalar function is given, so phi is given, so phi is equal to 3x square z minus y square z cube plus 4x cube y plus twice x minus 3y minus 5, right? So what it is asked? It is asked that what is the grad square phi. So we all know that grad square phi is basically del 2 phi del x2 plus del 2 phi del y2 plus del 2 phi del z2. So directly you can calculate in this way, or you can find out that is grad square phi is equal to divergence of gradient of phi. So either you first find out the what is the gradient of phi, then find out the divergence of this gradient of phi, it gives the same answer. So del 2 phi del x2 means the whole phi will be differentiated with respect to x 2 times. First del x of phi, so if I get the first del x of phi, where is the x term? X term is here. First identify where is the x term. এই ধরনের পার্সিয়াল ডিফারেন্সিয়েশন করতে গেলে প্রথমে দেখবে কোথায় কোথায় x টার্ম আছে, তাদের উপর এই del 2 phi del x2 কাজ করবে। এখানে একটা x টার্ম আছে। So first if I perform the del x of this term, it gives me 6xz. If I again perform del x of, so it gives me only 6z. So first I will get 6z. Del 2 phi del x2 again operated on this one. So first del x, first derivative del x of 4x cube y. So it gives me 12x square y. Then again second derivative, right? So it gives me 12, sorry not 12, it is x square, so it is 24xy. So plus 24xy. But if you perform the second order derivative with respect to x, it gives me 0. So the first term gives me 6z plus 24xy. What will give the second term? That is del 2 phi del y2. So first identify where is the y term. So y term is here, y term is there in y term is also here, and y term is here. So let's find out here del y of this one. So it gives me 2yz cube. Again differentiate with respect to y. So it gives me 2z cube. So first it is 2z cube with negative sign, so it is minus 2z cube. So if you perform here the first derivative, it gives me 4x cube. In the second derivative there is no y term, so it gives me again 0. And if I differentiate with respect to y 2 times, it gives me 0. So del 2 phi del y2 is minus 2z cube plus identify where is the z term. Z term is here, z term is also here. When you are performing the second order differentiation, okay, so then any term which contains the z, the power of z is more than 2, then you will get del 2 phi del z, otherwise it gives you 0. মানে এটা কি বললাম, যদি তোমাকে এরকম সেকেন্ড অর্ডার ডিফারেন্সিয়েশন করতে হয় তাহলে প্রথম তুমি দেখবে যে জেড টার্ম কোথায় কোথায় আছে। এবার যেহেতু এটা সেকেন্ড অর্ডার ডিফারেন্সিয়েশন, জেডের পাওয়ার যদি 2 এর বেশি হয় তাহলে তুমি দুবার ডিফারেন্সিয়েট করতে পারবে, নাহলে প্রথমবার ডিফারেন্সিয়েট করার পর দ্বিতীয়বার যখন করতে হবে তখন 0 হয়ে যাবে। তাহলে ফার্স্ট এখানে দেখো জেডের পাওয়ার কত, জেডের পাওয়ার ইজ অনলি 1. সো অবভিয়াসলি del 2 phi del z2 for this term gives you 0. Here z is 3, so we can get the 2 times differentiation. First time differentiation gives me 3y square z, second times differentiation gives me 3y square, sorry not 3, it is 3z square, 3y square z square, so it gives me 6y square z if I perform this. So let's do it here. So del y of y square z cube. So it not del y, it is del z. So it gives me 3y square z square. So again del z of this one, that is 3y square z square, it gives me 6y square z. So basically here we will get 6y square z, but it is a negative sign here, so we have to make here a negative sign. Okay, so is there any z term? So this term gives me 0, there is no z term, so this is the final answer. So answer is 6z plus 24xy minus twice z cube minus 6y square z. Okay, so now quick turn to problem number 73. It is an interesting problem, that is it is asked that the grad square log r. Okay, what it is expression. দেখো ভাই ভিডিও হয়তো লম্বা হয়ে যেতে পারে, প্রত্যেকটা প্রবলেমকে সলিউশন করতে গেলে লম্বা হবে, তোমরা স্কিপ করে যেতে পারো কিছু কিছু প্রবলেম, কারণ এর পরে যে প্রবলেমগুলো আসছে এগুলো খুবই ট্রিকি প্রবলেম এবং খুব সহজে যাতে সলভ করা যায় সেগুলো দেখাবো। সো নেক্সট অন দ্য প্রবলেমস হোয়াট এভার ইউ উইল ফাইন্ড হিয়ার আর ভেরি ট্রিকি অ্যান্ড I will teach you how to solve very quickly these problems. Okay, so basically we will use several formulas to solve the next problems. First 2-3 problems will be lengthy because there is no way to solve that one. Okay, so what is the log r? Log r means whatever r is here, it is nothing but the position vector. R means x I cap, so r means r vector means, always remember, it is x position vector x I cap plus y j cap plus z k cap. So that means r vector is so magnitude of r vector is r, so which is x square plus y square plus z square, right? So ln r means ln x square plus y square plus z square whole to the power half, or we can write it is nothing but half ln x square plus y square plus z square, right? So what is the grad square, this one? So grad square means del 2 del x2 which will be operated on this term, that is half ln x square plus y square plus z square term plus del 2 del y2 the same term plus del 2 del z2 with the same term, right? So I will solve only the first term and similarly I can write the second and the third term. So first, what is the del 2 del x2, this term we can write this is as del del x of this half ln x square plus y square plus z square, right? So this means that this half I can take outside or no problem if I put here. So del del x of this half I have taken here, so this is half, and del del x of log x, so it gives me 1 by the whole term x square plus y square plus z square, and according to the chain rule it gives me twice x. Okay, so these two cancelled, so basically it is del del x of x by x square plus y square plus z square. So if I use the ddx of u by v rule, so then I will get, it is nothing but the square of the denominator x square plus y square plus z square, and it gives me v, if it thinks it is u, it is v, so v into v means x square plus y square plus z square, v means this one, into del del x of u, so del del x of u means 1 minus x into ddx of this term, ddx of this term means we get 2x. So here is x square, here is 2x square, so it basically gives me y square plus z square minus x square by this will be square here. Okay, so x square plus y square plus z square whole square. So similarly I can write what is the del 2 over del y2, this del 2 del y2, not over, del 2 del y2 of this term. Just observe here, it is del 2 del x2 of this term, that is differentiation with respect to x, so here it is minus x square. Similarly, so y, it is the differentiation with respect to y, so similarly we can write the numerator will be x square plus y square, sorry, plus z square minus y square, right? And the denominator should be same, that is x square plus y square plus z square whole square. Okay, so similarly del 2 del z2 of this function gives me x square plus y square minus z square, and it is x square plus y square plus z square whole square. Okay, so if I add all these things, that is del 2 del x2 plus del 2 del y2 del 2 del z2, then I will get this grad square log r. So grad square ln r, if I add all these things, what we will get here, I will get the x square plus y square plus z square divided by x square plus y square plus z square whole square. So, that means 1 by x square plus y square plus z square, that means 1 by r square. Okay. Now, take another problem. So, this is problem number 74. This is not a problem, but a formula. We have to prove that one. So, problem number 74, it is asked that prove that grad square r to the power n, very important formula, grad square r to the power n is equal to n into n plus 1 r to the power n minus 2. We have to prove that one, right? ভালো করে লক্ষ্য করবে, এখানে আমি অনেকগুলো ফর্মুলা ইউজ করে খুব সহজে এটাকে প্রুভ করব। সো আই উইল ইউজ সেপারেট ফর্মুলাস and very easily we can prove that one. So, what is the grad square of a scalar function? So, grad square r to the power n, we can write it as divergence of the gradient of r to the power n, right? We can write that one, and we all know that what is the gradient of r to the power n. So, we know that so we can write here it is divergence of gradient of r to the power n means n r to the power n minus 2 r vector. So, now n, I can take this n outside. So, divergence of phi a, we can think this is the phi and this is a vector, and we all know that divergence of phi a vector is equal to gradient of phi dot a vector plus phi divergence of a vector, right? So, you will use this formula here. So, it gives me gradient of what is the phi, r to the power n minus 2, okay, dot a vector, that means r vector here, plus r to the power n minus 2 divergence of r vector, okay. So, this is n gradient of, so this is not the dot things, this is multiplication. So, gradient of r to the power n minus 2 r vector, okay. This is dot dot, so this is dot dot product, I forgot that one, sorry, it's my mistake, this is the dot product. So, gradient of r to the power n minus 2, again we can use the formula. So, it is n gradient of these things means n minus 2 r to the power n minus 2 r vector, again dot r vector, right? And this one gradient divergence of position vector is always gives you the 3. So, it is 3 r to the power n minus 2, okay. So, this is n minus 2, this r dot r gives me r square, and again it is r to the power n minus 2. So, if I take this r square, so there will be a plus 2. So, it is basically r to the power n minus 2 plus 3 r to the power n minus 2, okay. So, this is n, we can write here it is n minus 2, if I take r to the power n minus 2 as a common, so minus 2 plus 3 r to the power n minus 2, right. So, this basically n into n plus 1 r to the power n minus 2. So, hence the formula is proved here, okay. So, now take another problem from the Spiegel book, that what it is asked? It is asked that problem number 79, that find out the divergence of r cube r vector. So, you will use the same formula, divergence of phi a. So, that means it is gradient of r cube. Always remember that what is the scalar one, what is the vector one. So when divergence of the multiplication of scalar and vector, so gradient will be the scalar dot r vector plus scalar one, that is r cube, divergence of r vector. Okay. And gradient of r cube, you all know that gradient of r to the power n, so 3 r to the power n minus 2, that is 3 minus 2 r vector dot r vector plus divergence of r vector is always 3, so it is 3 r cube. So what it is? It is 3 r to the power r, here it is r square, r dot r is r square plus 3 r cube. So basically it is 3 r cube plus 3 r cube, it is 6 r cube. Okay. Problem number 80. Problem number 80 is, it is asked what is the divergence of r vector gradient of 1 by r cube. Again the same type of problem. This is a vector, gradient of 1 by r cube, gradient of any scalar function is a vector. So you can think this is a vector, a vector, and this should not be vector. So this is phi, okay, scalar function. So what you will get here? You will get basically gradient of r dot gradient of 1 by r cube, because gradient of phi dot a vector means gradient of 1 by r cube, plus r as it is divergence of this a vector means gradient of 1 by r cube. Okay. Okay. So we will use several formulas here. So gradient of r means we can r to the power 1, we can think this is the r to the power 1. So r to the power 1 means n is 1 into n minus 2, that is 1 minus 2, and r to the power n minus n into n minus 2 into r vector. So we do not use this dot here. So gradient of, what we know that gradient of r to the power n is n r to the power n minus 2 r vector, right? This is the formula. So n is 1 here, 1 r to the power n minus 2, that is 1 minus 2, and r vector, right? Okay. Dot gradient of r to the power minus 3, this is gradient of 1 by r cube means gradient of r to the power minus 3. Okay. So r to the power minus n again, so n is equal to minus 3 here, so it is minus 3 r to the power minus 3 minus 2, right, r vector, plus this is r as it is divergence of gradient of these things. So that means we can write divergence of gradient of something means grad square 1 by r cube, or grad square 1 by r cube, I can write it is grad square r to the power minus 3. Okay. So this is r vector dot r vector means r square. So first here I will get one, let us write this is 1, so it is minus 3, so it is minus 3 r to the power minus 1, here r to the power minus 5, and r dot r gives you r square, plus r grad square r to the power n, what we have found out just right, grad square r to the power n is equal to n into n plus 1 r to the power n minus 2. So r n into n means minus 3 into r to the power, sorry, n into n plus 1, so minus 3 plus 1 into r to the power n minus 2, so the r to the power minus 3 minus 2. So what is here? So it is minus 1 minus 5, that is minus 6 plus 2, that is minus 4. So 3 r to the power minus 4. What we will get? It is minus 3 plus 1, that is minus 2 into minus 3, that is 6. So it is plus 6 r to the power minus 5, and 1 r is here, so it is r to the power minus 4. So basically it is 3 r to the power minus 4. Okay. Now problem number 81, Spiegel book. It is asked what is the grad square divergence of r vector by r square. Okay. Okay. So here I have generated one formula for these things, that is divergence of this type of problem r vector by r to the power n. Basically it follows this formula minus n minus 3 r to the power minus n. Okay. So here if I use this formula, it is grad square divergence of r vector by r square, n is equal to 2 here. So it is minus n is 2 minus 3 r to the power minus 2. So it is 2 minus 3 minus 1, again minus, so it is 1 basically. So finally what we will get, it is grad square r to the power minus 2, again it is grad square r to the power n. So n into, that is minus 2 into n plus 1, that is minus 2 plus 1 r to the power n minus 2, that is minus 2 minus 2. So it is basically 2 r to the power minus 4. So only 3 lines are sufficient to solve that one. So if you use this formula, any type of problem for the divergence, this type of problem you can solve that one, right? Otherwise you have to take lots of things, lots of lines will be there, অনেক লাইন তোমাদের করতে হবে, তারপরে প্রবলেম সলভ করতে পারবে। ওকে, now another problem. This is 82, problem number 82, and I believe that if you solve this type of problems, any problem you can solve by yourself. Problem number 82, Spiegel book. So a vector, this is also a simple problem, a vector is equal to r vector by r, and it is asked that what is the gradient of divergence of a vector. Okay. So it is very simple. First, divergence of a vector, what is this? Divergence of a vector is equal to divergence of r vector by r. So we will use r vector by r to the power n formula. So I am writing one again. So divergence of r vector by r to the power n, it is minus n minus 3 r to the power minus n. So what is the n here? N is 1 here. Okay. So this is basically, so divergence of a vector is nothing but minus 1 minus 3 r to the power minus 1. So this is 2 r to the power minus 1. So 2 r to the power minus 1. So now what is the gradient of, gradient of divergence of A? That means it is gradient of 2 r to the power minus 1. So we can write it is 2 gradient of r to the power minus 1. Again we know what is the gradient of r to the power n. So it is 2 n into, that is minus 1 into r to the power n minus 2. So minus 1 minus 2 into r vector. So this one. So basically it gives me, it is nothing but minus 2 r to the power minus 3 r vector. Okay. So I think that's all for the divergence related problems. If you find any problem which becomes very complicated or hard to you, then you can write in the chat box. Okay. In the next video I will discuss some important problems, not all the problems, some important problems related to the curl, and also we will start vector integration. Either I will start the vector integration or this gradient divergence curl in the curvilinear coordinate system. So till now we have used only the Cartesian coordinate system, where we have used this is x, y and z. Okay. But there are another coordinate systems also, cylindrical coordinate systems, and the spherical coordinate systems. What will be the expression for the nabla in these two systems? I will discuss that one. And what will be the divergence, gradient and curl in these two systems. Okay, these are also important. That's all of the for the day. We will meet one again. Okay, bye.